We have the rate constant at two different temperatures. We're asked to calculate the activation energy. So this is an Arrhenius problem. We could solve the Arrhenius problem if we had multiple values of K at different temperatures. We could do an Arrhenius plot where we can plot K versus 1 over T, and our slope would give us minus EA over R. So once we have our plot, calculate our slope, multiply it by minus R, and we get our activation energy. It's a graphical solution. But since there's only 2 points, an easier method is to solve via the following equation, where we put in these values and we can solve for EA. So first let's rearrange this equation and solve for EA. So we have EA is going to be equal to minus R times ln of K2 to K1 divided by 1 over T2, 1 over T1. And let's plug in the values. R we want in terms of joules, so this is going to be minus 8.314, and we'll plug in K2, K1, and divide by the appropriate values. So let's go over some calculator skills. Let's talk about some strategic calculator skills. The way that I would put this denominator, get a numerical value in my calculator, is to say 298 to the minus 1 minus 293 to the minus 1. And the result would be this here. So essentially, the result is that we have this numerator value, I've just copied this down here, and we're dividing by this. While this number, this pink result, is still in my calculator display, I hit to the minus 1, and that takes the reciprocal of this value, which numerically is equal to this. And that makes this calculation effectively the following. Okay, the result is this is all a multiplication. So this is the denominator value here. So we've gotten it into our calculator display, hit to the minus 1, taken its reciprocal, and now that this number is in its display, the display of the calculator, we multiply it by negative 8.314 and the natural log of this ratio. And we finish the problem accordingly. So this result is here, and this is going to be in units of joules per mole. We convert that to kilojoules per mole for our final answer.